Hello, you guys. It's Miss All Day again. We are on day 2 of chapter 13. Yesterday, we did 13.1, which was experimental and theoretical probability. Today, we're going to do 13.2. So if you want to turn to page 830, you can, but all your notes and everything you need is going to be right here, so you don't really have to. All right, today is Wednesday, April the 29th, and we're just going to get started. All right, we're going to start out with looking at this table. This is a table that shows the speeds of cars as they pass a certain mile marker on Highway 66. Now, the speed limit here on Highway 66 is 65 miles per hour. So we're looking at what is the total number of cars that pass the marker. Now, this is supposed to be a less than sign. I don't know why it turned out like that, but it did. Some cars were going less than 55. There were 2 cars. There were some cars going in between 55 and 60. There were 12 cars. Between 60 and 65 miles per hour, there were 23 cars. And going 65 miles per hour, there were 13 cars. What is the total number of cars that passed the marker? So go ahead and add up all those cars and tell me how many cars passed the marker. It was a certain mile marker on Highway 66. All right, you should have gotten 50. We're going to write that down here. Total number of cars that passed the marker. And now we want to know what is the probability. So we write it like this. We put P and then we put it in parentheses. Normally it's not that long, but this one is. What is the probability that a car stopped at random will be traveling faster than the speed limit? Now, the speed limit is 65 miles per hour, right? So the probability that someone is going to be going greater than 65 miles per hour is going to be 0, because I don't see any cars here that are going greater than 65 miles per hour. They're all going less than 55, 55 to 60, 60 to 65, or 65 miles per hour. No one's speeding. So the probability of that happening is going to be 0. All right? I'm sure you remember doing this in other math classes. Might just be a review for you. So this should be a quick lesson for you. All right. All right, so you just used a frequency table to calculate probability. A frequency table is a data display that shows how often an item appears in a category. So here we have the category. These are the number of cars that did the certain amount of speed. So you see how often different cars went different miles per hour. All right. Relative frequency is the ratio of the frequency of the category to the total frequency. So you can use relative frequency to approximate the probability of events. So that's what we're going to do now. We're going to find relative frequency. All right, the survey on the right, the results of a survey of a student's music preference. Now this should be an S with an apostrophe. I'll fix that in your copy. The results of a survey of students' music preferences are organized in this frequency table. So this is a frequency table. You see how often something occurs, frequent. What is the relative frequency of the preference for rock music? All right, so there's a couple of things that you're going to have to do to find this out. In order to do relative frequency, you're going to do the frequency of rock music preference over the total frequency. All right, so the first thing you have to do is you have to go find rock, and you see that it's 10. All right, so it's going to be 10 out of, and what you're going to have to do is you're going to have to add up all those numbers. So it's 10 over 10 plus 7 plus 8 plus 5 plus 6 plus 4. Okay, so it's going to be 10 over, go ahead and add those up and see what you get. I would probably do it like this. This is 10, this is 10, this is 15, this is 5. Add them like that. You can do it real quick. All right, so you should have got 40, and then you want to reduce, and you want to say 1/4. So the relative frequency of rock music being the preference is 1/4. So that's your answer. All right. Now you're going to do the got it problem number 1, A, B, C, and D, located on the next page, page 831. But what I did is I did like I did yesterday, and I have got it number 1 right here all set and ready for you. If you want to go do it right now, you could stop the video and go ahead and do it right now while you're in the mode of what a relative frequency is. Okay, I'm going to move on though, and we're going to go to the next page of your notes, problem 2. We're going to calculate the probability by using relative frequencies. All right. All right. A student conducts a probability experiment by tossing 3 coins, one after the other. Using the results below, what is the probability that exactly 2 heads will occur in the next 3 tosses? So this is what could happen. You could toss heads, heads, heads if you did it 3 times in a row. Okay? You could do heads, heads, tails. You could do heads, tails, tails, heads, tails, heads, tails, heads, heads, tails, heads, tails, 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 or tails, tails, heads. Now, they actually did it. And the numbers underneath is how many times that occurred. So remember, we want exactly 2 heads. So we're going to find the number of times that it results in exactly 2 heads. Okay, so that's our first step. Let's put how many times? How many times there's 2 heads? All right, so I see at least 2 here. I see at least 2 here. I see at least 2 here. And I see at least 2 here. All right, do you see all those? Exactly 2 heads. All right. Now, did you notice that I circled 1? I think I paused myself, excuse me. Did you notice I circled 1 that I should not have circled? Because they want exactly 2 heads. Which one should I have not circled? I should not have circled the 3 heads because they only wanted 2. So we're going to get rid of that one. Okay, so we're going to add together 7 plus 6 plus 2. Yes, so you know that this is 15. All right, sorry about that. Sorry, my writing's not very neat. I hope you can read it. It's just hard to write up on the screen. All right, so now the next thing you want to do, the second step, is you want to go ahead and add all the total frequencies, all these. So you're going to do 5 plus 7 plus 9 plus 6 plus 2 plus 9 plus 10 plus 2. All right, go ahead and pause your video and add those. All right, you should have gotten 50. All right, so your third step is you are going to find the relative frequency of a trial that has exactly 2 heads. So we're going to put relative frequency. So we're going to do, I'm just going to write exactly 2 heads over the total frequency. Now you could put the frequency of exactly 2 heads, but you know what I mean. So that's 15 over 50. All right, divide both by 5. You should get 3 over 10. So based on the data collected, the probability that the next toss will be exactly 2 heads is going to be 3/10. All right, now you're going to do the got it problem number 2 on the same page, 831. I put it on this last page for you right here. Okay, it's about a spinner, and they have a frequency table all ready for you. All right, go ahead and scroll down to the next one, problem 3, but right above problem 3, a probability distribution shows the probability of each possible outcome. A probability distribution can be shown in a frequency table. All right, so let's find a probability distribution. This is archery, by the way. I don't know if you guys have done that before. I think I have, but it's been a long time. In a recent competition, 50 archers shot 6 arrows each at a target. 3 archers hit no bullseyes. 5 hit 1 bullseye. 7 hit 2 bullseyes. 7 hit 3 bullseyes. 11 hit 4 bullseyes. 10 hit 5 bullseyes. 7 hit 6 bullseyes. What is the probability distribution for the number of bullseyes each archer hit? Now, there's not supposed to be an E there. I'll fix that on my original. All right, so I like to title mine first. So I title it the probability distribution of bullseyes hit. Okay, and then you want to have some labels. You want to have the number of bullseyes that are hit. So for instance, we're going to start with no bullseyes, right? So the number of bullseyes hit would be 0. And how many people hit 0? It would be 3. All right, and how would you write that as a probability? You're going to put 3 over, and remember they said that there were 50 of them. So I'm going to put 3 over 50. All right, let's go to the next one. 1 bullseye was hit by 5 people. That's going to be 5 over 50. All right, 2 bullseyes were hit by 7 people. That's 7 over 50. 3 bullseyes were hit by 7 people. 7 over 50. 4 bullseyes were hit by 11 people. It's going to be 11 over 50. 5 bullseyes were hit by 10 people. It's going to be 10 over 50. And 6 bullseyes were hit by 7 people. And that's 7 over 50. Okay, so this table helps you find the relative frequencies for each number of the bullseyes. And the relative frequencies are the probability distribution. So that's the probability distribution. Now, if they wanted to particularly ask you a question, like what's the probability of getting hitting 2 bullseyes? That's 7 over 50. And you don't have to reduce it because it's already simple. That's just if they asked you a particular one. That is not the question in this one. They wanted to know what is the probability distribution. All right, and then you have got it problem number 3. This is on page 832, the same page I got this problem from, and I put it right down here. So those are the 3 problems that you need to upload for your 13-2 assignment. This is optional down here. You do not have to do these. They're there for practice if you want to do them. All right? All right, see you guys later. Bye.